Hey everybody, it's Jenny from Norman S. Wright. Let's continue on with our pump topics. This week I want to talk about how to read a pump curve. So let's get started.
So let's start by pulling up a pump curve. Pump curves show the operating range of a pump. Pump curves show head going up in this direction and flow going across the bottom. Head is measured in feet and flow is measured in gallons per minute, GPM. We'll talk about the rest of this in a minute. Different types of pumps will have different curves, but they all tell you the same thing. This line is the pump curve. It shows the flow the pump will produce at a given head. As you increase your head, your flow decreases. Let me move this over a minute and talk about this a little more. One way to think about it is if you have a pump pushing water through a horizontal pipe, you'll get maximum flow because you're not working against any gravity. As you have to push the water higher, you get less flow out the end. So if it's pushing straight up, you get 0 GPM, and in the middle, you're somewhere in between. So let's move this back and look at our curve again. On this end, you have the maximum head, which is about 47 feet on our curve. And you would get 0 GPM flow out of this. This is the shutoff head, also called the dead head. You don't want to operate a pump in this condition. On the other end of this curve, you have the minimum operating range, which is about 26 feet of head at 660 GPM. The curve also shows you the preferred operating range, which was already highlighted a bright blue before I highlighted the whole curve with my lighter blue line. And this goes from about 350 to 590 GPM. And if you follow the preferred range back over here, you can see that the pump will do 350 GPM at 42 feet of head and 590 GPM at about 30 feet ahead. And at the point of highest flow on the curve, 660 GPM at 27 feet ahead, you increase the risk of cavitation, which we discussed in last week's video. A fixed speed pump will always operate along this pump curve line. If there are multiple lines, each line represents a different pump speed. And then over here, we have the impeller size for this pump, which is 7.09 inches. The system curve is where the head originates from friction loss only. Where your system curves intersects your pump curve is the operating point of your selected pump. In this example, if this pump is put in this system, it has a total head of about 35 feet and will result in a flow of 625 GPM. Next, we have the pump efficiency curve. If you follow the operating point to the efficiency curve, you'll see the efficiency at your operating point. In our case, this pump will be about 82% efficient at our operating point. Ideally, you'll want to operate your pump as close to peak efficiency as possible, and we're pretty much there on our curve here. The pump chart will also show you the pump power curve. If we follow our operating point to the power curve, you'll see that we need just under 6 horsepower motor to operate this point. As flow increases, so does the horsepower you need to operate your pump. Next, we have the NPSR curve. So if we follow our operating point down, you'll see that the NPSHR is around 10 feet. I need just a little more room. We talked about this last time. It's the curve used to determine the amount of head required by the pump at its operating point in order to prevent the risk of cavitation. So that's how you read a pump curve. Don't forget to like and subscribe to our YouTube channel, and thanks for watching.